plan to install a 60 amp subpanel and run underground feeder cable from the home to the panel is a reasonable approach for providing power to the pool and other future electrical needs. However, there are several important considerations to address. Firstly, voltage drop will be a significant factor in the project. With a 220-foot feeder run and another 80-foot for the pool pump and light, the total cable length is 300 foot. Using number 3 American wire gauge, or AUG, conductors will provide adequate voltage drop protection. Secondly, proper grounding is crucial for the safety of the pool. It must be ensured that the subpanel is properly grounded to the main electrical panel at the home. Additionally, the pool pump and light require separate grounding connections. Thirdly, in addition to grounding, the pool structure itself must be bonded to the electrical system. This involves installing a bonding wire that connects the pool shell, any metal components, and the electrical ground. Fourthly, polyvinyl chloride, or PVC, conduit is a suitable choice for protecting the conductors from the subpanel to the pool area. However, using recessed electrical boxes for the receptacles and pool light may be considered, as they provide a more professional and secure installation. Fifthly, the loads for the pool pump, pool light, and other future electrical needs will need to be determined. This will help ensure that the subpanel and feeder wire are sized appropriately. The cost of the project will vary depending on several factors, including local labor rates, material costs, complexity of trenching and excavation, and permit fees. Calculate the loads for all electrical devices. Determine the appropriate gauge and type of feeder wire for the voltage drop requirements. Ensure that the subpanel is properly grounded and bonded. Install the subpanel, run the feeder wire, and terminate the conductors. Install conduit and recessed electrical boxes for the pool pump, pool light, and future electrical needs. Obtain the necessary permits and inspections. When planning an electrical installation for a pool, several key factors must be considered to ensure safety and compliance with electrical codes. The first consideration is voltage drop. Voltage drop refers to the decrease in voltage that occurs as electricity flows through a conductor over a distance. In pool installations, where the distance from the power source to the pool equipment can be significant, voltage drop can be a major issue. Excessive voltage drop can cause equipment to malfunction or even fail, and it can also create a safety hazard. To mitigate voltage drop, it is crucial to select the appropriate size conductor for the length of the run and the amount of current that will be flowing through it. Electrical codes typically specify the maximum allowable voltage drop for different types of circuits, and these limits must be adhered to. Factors that influence voltage drop include the length of the wire, the gauge of the wire, the amount of current flowing through the wire, and the type of wire used. Using a larger gauge wire will reduce voltage drop, as will shortening the length of the wire run. The second consideration is grounding and bonding. Grounding and bonding are essential for preventing electrical shock hazards in pool areas. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or ground fault circuit interrupter, or GFCI, and energizing the circuit. Bonding involves connecting all metal parts of the pool and its surrounding structures to create an electrically continuous system. This helps to equalize the voltage potential between different metal parts, reducing the risk of electric shock if a fault occurs. The grounding system should be connected to the main electrical panel and should include a grounding electrode, such as a ground rod or ground plate, that is buried in the earth. All metal parts of the pool, including the pool shell, the reinforcing steel, the metal fittings, and the metal equipment, must be bonded together using a solid copper bonding conductor. The bonding conductor should be sized according to electrical code requirements and should be connected to all metal parts in a manner that ensures a reliable electrical connection. The third consideration is ground fault circuit interrupters, or GFCIs. GFCIs are devices that are designed to protect people from electric shock by detecting ground faults and quickly interrupting the flow of electricity. GFCIs are required in all electrical circuits that serve pool equipment, such as pool pumps, pool lights, and pool heaters. They are also required for receptacles that are located within a certain distance of the pool. A GFCI works by monitoring the current flowing in the hot and neutral conductors of a circuit. If there is a difference in current between the two conductors, it indicates that some of the current is leaking to ground, which could be due to a fault in the equipment or a person coming into contact with a live wire. When a GFCI detects a ground fault, it quickly trips the circuit, cutting off the flow of electricity and preventing electric shock. The fourth consideration is electrical codes and regulations. Electrical codes and regulations vary depending on the location, but they are all designed to ensure the safe installation and operation of electrical systems. In the United States, the National Electrical Code, or NEC, is the most widely adopted electrical code. The NEC contains specific requirements for pool electrical installations, including requirements for grounding, bonding, GFCI protection, wiring methods, and equipment placement. It is essential to be familiar with the electrical codes and regulations that apply in the area where the pool is being installed and to ensure that the electrical installation complies with all applicable requirements. The fifth consideration is wiring methods. The wiring methods used in pool electrical installations must be suitable for the wet and corrosive environment. Wiring must be protected from physical damage and must be installed in a manner that prevents water from entering the electrical system. Common wiring methods for pool electrical installations include PVC conduit, rigid metal conduit, and underground feeder cable. PVC conduit is a non-metallic conduit that is resistant to corrosion and is suitable for use in wet locations. Rigid metal conduit is a more durable conduit that is suitable for use in areas where the wiring is subject to physical damage. Underground feeder or UF cable is a type of cable that is designed for direct burial in the earth. When using UF cable, it must be buried at the depth specified by the electrical code and must be protected from physical damage. The sixth consideration is equipment placement. The placement of electrical equipment around the pool is also important for safety. Electrical equipment, such as receptacles, switches, and lighting fixtures, must be located at a safe distance from the pool to prevent electric shock hazards. Electrical codes typically specify the minimum distances that electrical equipment must be located from the pool. For example, receptacles must typically be located at least 10 feet from the inside wall of the pool, and lighting fixtures must be located at least 12 feet above the maximum water level. The seventh consideration is pool lighting. Pool lighting can enhance the aesthetics of the pool and can also improve safety by providing illumination for swimming at night. However, pool lighting must be installed in accordance with electrical code requirements to prevent electric shock hazards. Pool lights must be specifically designed for underwater use and must be listed by a recognized testing laboratory. Pool lights must be installed in a manner that prevents water from entering the electrical system, and they must be grounded and bonded in accordance with electrical code requirements. The eighth consideration is bonding of metal parts. Proper bonding of all metal parts in and around the pool is crucial for preventing electrical shock hazards. Bonding involves connecting all metal parts together with a solid copper bonding conductor to create an electrically continuous system. This helps to equalize the voltage potential between different metal parts, reducing the risk of electric shock if a fault occurs. All metal parts of the pool, including the pool shell, the reinforcing steel, the metal fittings, the metal equipment, and any metal fences or structures around the pool, must be bonded together. The bonding conductor should be sized according to electrical code requirements and should be connected to all metal parts in a manner that ensures a reliable electrical connection. The ninth consideration is inspections and permits. Before starting any electrical work on a pool, it is important to obtain the necessary permits from the local building department. The building department will typically require a set of plans showing the electrical installation, and they will inspect the work to ensure that it complies with electrical codes and regulations. Obtaining permits and inspections is essential for ensuring the safety of the electrical installation and for avoiding potential fines or penalties. The 10th consideration is surge protection. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges, such as those caused by lightning strikes or power line disturbances. Voltage surges can damage or destroy sensitive electronic equipment such as pool pumps, pool heaters, and pool control systems. SPD are installed in the electrical panel and are connected to the electrical circuits that serve the pool equipment. When a voltage surge occurs, the SPD diverts the surge current to ground, protecting the equipment from damage. The 11th consideration is hiring a qualified electrician. Electrical work on poles can be complex and dangerous, and it is essential to hire a qualified electrician to perform the work. A qualified electrician will be familiar with electrical codes and regulations, and they will have the experience and expertise to install the electrical system safely and correctly. When hiring an electrician, it is important to check their credentials and to ensure that they are licensed and insured. It is also a good idea to get multiple bids from different electricians to compare prices and services. The 12th consideration is the National Electrical Code, or NEC Article 680. The NEC Article 680 provides specific requirements for electrical installations in and around swimming pools, spas, hot tubs, and other similar bodies of water. This article covers a wide range of topics, including grounding, bonding, GFCI protection, wiring methods, equipment placement, and pool lighting. It is essential to be familiar with the requirements of NEC Article 680 when planning and installing electrical systems for pools. Some of the key requirements of NEC Article 680 include the following. All electrical equipment used in or around pools must be listed for the intended use and must be installed in accordance with the manufacturer's instructions. All electrical circuits that serve pool equipment must be protected by GFCIs. All metal parts of the pool and its surrounding structures must be bonded together to create an electrically continuous system. Wiring methods used in pool electrical installations must be suitable for the wet and corrosive environment. Electrical equipment must be located at a safe distance from the pool to prevent electric shock hazards. Pool lighting must be installed in accordance with electrical code requirements to prevent electric shock hazards. The 13th consideration is equipotential bonding. Equipotential bonding is a method of bonding that is used to minimize voltage differences between different metal parts in and around the pool. This is achieved by connecting all metal parts together with a solid copper bonding conductor to create an electrically continuous system. The equipotential bonding system should include all metal parts of the pool, including the pool shell, the reinforcing steel, the metal fittings, the metal equipment, and any metal fences or structures around the pool. The bonding conductor should be sized according to electrical code requirements and should be connected to all metal parts in a manner that ensures a reliable electrical connection. The purpose of equipotential bonding is to reduce the risk of electric shock by ensuring that all metal parts are at the same voltage potential. If a fault occurs in the electrical system, the equipotential bonding system will help to distribute the fault current evenly, reducing the voltage difference between different metal parts and minimizing the risk of electric shock. The 14th consideration is swimming pool and spa drain covers. Federal law requires that all public and commercial swimming pools and spas have drain covers that comply with the Virginia Graham-Baker Pool and Spa Safety Act, or VGBA. The VGBA was enacted in 2007 in response to a series of drowning incidents involving children who became entrapped by pool or spa drains. The VGBA requires that all pool and spa drain covers meet certain safety standards and that they be properly installed and maintained. The purpose of the VGBA is to prevent drain entrapment and to reduce the risk of drowning in pools and spas. Pool and spa owners are responsible for ensuring that their drain covers comply with the VGBA and that they are properly installed and maintained. Failure to comply with the VGBA can result in fines and penalties. The 15th consideration is electrical subpanels. The plan to install a 60 amp subpanel is a common and effective way to provide power to pool equipment and other electrical loads in the pool area. A subpanel is a smaller electrical panel that is fed from the main electrical panel and is used to distribute power to specific circuits. Installing a subpanel near the pool can simplify the wiring and can reduce the voltage drop in the circuits that serve the pool equipment. When installing a subpanel, it is important to follow electrical code requirements and to ensure that the subpanel is properly grounded and bonded. The subpanel should be sized appropriately for the loads that it will be serving, and it should be protected by a main circuit breaker. The wiring from the main electrical panel to the subpanel should be sized according to electrical code requirements and should be installed in a manner that protects it from physical damage. By carefully considering these factors and following electrical code requirements, it is possible to create a safe and reliable electrical system for a swimming pool or spa. It is always recommended to consult with a qualified electrician before starting any electrical work on a pool to ensure that the installation is done correctly and safely. A critical aspect of pool electrical systems involves adherence to National Electrical Code, or NEC guidelines, particularly Article 680. This article provides comprehensive safety standards for electrical installations in and around swimming pools, spas, hot tubs, and similar locations. Understanding and implementing these guidelines is crucial for preventing electrical hazards and ensuring the safety of pool users. Several key areas within NEC Article 680 directly impact pool electrical installations. Firstly, grounding and bonding requirements are paramount. Grounding ensures a safe path for stray electrical currents to return to the source, tripping circuit breakers and preventing shocks. Bonding connects all metallic parts of the pool structure, such as ladders, handrails, and lighting fixtures, to create an equipotential plane, minimizing voltage differences and reducing the risk of electric shock. Secondly, ground fault circuit interrupter, or GFCI, protection is essential for all electrical circuits serving pool equipment. GFCIs detect even small amounts of leakage current and quickly cut off power, preventing potentially fatal shocks. These devices are required for outlets near the pool, underwater lighting, and other electrical equipment in the pool area. Thirdly, wiring methods and materials must be suitable for the wet and corrosive environment around a pool. Conduit, such as PVC or rigid metal, protects wiring from physical damage and moisture. Wiring must be properly insulated and sized to handle the electrical load. Fourthly, clearances and locations of electrical equipment are strictly regulated. Outlets, switches, and lighting fixtures must be placed at specific distances from the pool's edge to prevent accidental contact with water. Underwater lighting must be specifically designed and listed for pool use. Fifthly, bonding of metal parts is another key requirement. All metal parts within a certain distance of the pool, including fences, gates, and other structures, must be bonded together to create an equipotential plane. This further reduces the risk of electric shock by minimizing voltage differences. In addition to these specific requirements, NEC Article 680 also covers topics such as the use of transformers, low voltage lighting, and the installation of underwater audio equipment. It is essential for anyone involved in pool electrical work to have a thorough understanding of NEC Article 680 and to follow its guidelines carefully. Failure to comply with NEC requirements can result in serious electrical hazards, including electric shock, fire, and even death. It is always recommended to consult with a qualified electrician who is familiar with NEC Article 680 before starting any pool electrical work. They can help to ensure that the installation is safe, compliant, and meets all applicable codes and regulations. Furthermore, local codes and regulations may also apply to pool electrical installations. It is important to check with the local building department to determine any additional requirements that may be in place. Obtaining the necessary permits and inspections is also essential for ensuring that the electrical work is done correctly and safely. In summary, NEC Article 680 provides a comprehensive set of safety standards for pool electrical installations. By understanding and following these guidelines, you can help to prevent electrical hazards and ensure the safety of pool users. Always consult with a qualified electrician and obtain the necessary permits and inspections before starting any pool electrical work. Proper voltage drop calculations are paramount when planning any electrical circuit, and this holds especially true for pool installations due to the often considerable distances involved between the power source and the equipment. Voltage drop refers to the reduction in voltage that occurs as electricity flows through a wire over a certain length. Excessive voltage drop can lead to various problems, including reduced equipment performance, overheating of wires, and even equipment failure. To accurately calculate voltage drop, several factors need to be considered. Firstly, the length of the wire run is a critical factor. The longer the wire run, the greater the voltage drop. Secondly, the amperage of the circuit is another important consideration. The higher the amperage, the greater the voltage drop. Thirdly, the wire gauge plays a significant role. Thicker wires have lower resistance and therefore experience less voltage drop. Fourthly, the type of wire used also affects voltage drop. Copper wires, for example, have lower resistance than aluminum wires, resulting in less voltage drop. Several formulas and online calculators can be used to calculate voltage drop. One common formula is voltage drop equals 2 times K times I times D divided by circular mils, where K is a constant representing the wire's resistance, I is the amperage, D is the one-way distance in feet, and circular mils is the wire's cross-sectional area. Online calculators can simplify the process by automatically performing the calculations based on the input parameters. To minimize voltage drop and pull installations, several strategies can be employed. Firstly, using a larger wire gauge can significantly reduce voltage drop. Thicker wires have lower resistance and can carry more current with less voltage loss. Secondly, shortening the wire run whenever possible can also help to minimize voltage drop. Thirdly, using copper wires instead of aluminum wires can further reduce voltage drop due to copper's lower resistance. Fourthly, ensuring that all connections are tight and secure can prevent voltage drop caused by loose connections. In addition to these strategies, it is important to consider the voltage drop limitations specified by electrical codes. The National Electrical Code, or NEC, for example, recommends that voltage drop should not exceed 3% for branch circuit and 5% for feeders. Adhering to these limitations helps to ensure that equipment operates properly and safely. Furthermore, voltage drop calculations should be performed for all circuits serving pool equipment, including pumps, heaters, lighting, and other electrical devices. Accurate calculations can help to determine the appropriate wire gauge and ensure that the equipment receives the required voltage. In conclusion, proper voltage drop calculations are essential for pool installations. By considering the factors that influence voltage drop, using appropriate formulas or calculators, and implementing strategies to minimize voltage drop, it is possible to ensure that equipment operates efficiently and safely. Consulting with a qualified electrician is always recommended to ensure that voltage drop calculations are performed correctly and that the electrical system meets all applicable codes and regulations. Proper grounding and bonding are crucial components of any electrical system, but they are especially critical in pool installations due to the inherent risks associated with water and electricity. Grounding provides a safe path for electrical current to flow back to the source in the event of a fault, while bonding connects all metallic parts of the pool structure to minimize voltage differences and prevent electrical shock. Grounding involves connecting the electrical system to the earth through a grounding electrode, such as a ground rod or ground plate. This connection provides a low resistance path for fault current to flow back to the source, tripping a circuit breaker or ground fault circuit interrupter, or GFCI, and energizing the circuit. Bonding, on the other hand, involves connecting all metallic parts of the pool structure, including the pool shell, the reinforcing steel, the metal fittings, and the metal equipment, to create an electrically continuous system. This helps to equalize the voltage potential between different metal parts, reducing the risk of electric shock if a fault occurs. Several key requirements for grounding and bonding in pool installations are specified in the National Electrical Code, or NEC. Firstly, all electrical equipment used in or around pools must be properly grounded. This includes pumps, heaters, lighting, and other electrical devices. Secondly, all metallic parts of the pool structure must be bonded together. This includes the pool shell, the reinforcing steel, the metal fittings, and the metal equipment. Thirdly, a solid copper bonding conductor must be used to connect all metallic parts. The bonding conductor must be sized according to NEC requirements and must be connected to all metal parts in a manner that ensures a reliable electrical connection. Fourthly, the bonding conductor must be run continuously and without splices. This helps to ensure that the bonding system is effective in equalizing voltage potentials. Fifthly, the bonding conductor must be connected to a common bonding grid. The bonding grid provides the central point for connecting all bonding conductors and helps to ensure that all metallic parts are at the same voltage potential. Sixthly, ground fault circuit interrupters, or GFCIs, must be used to protect all electrical circuits serving pool equipment. GFCIs detect even small amounts of leakage current and quickly cut off power, preventing potentially fatal shocks. In addition to these requirements, it is important to follow best practices for grounding and bonding in pool installations. Firstly, use corrosion-resistant materials for all grounding and bonding connections. This helps to prevent corrosion from compromising the effectiveness of the grounding and bonding system. Secondly, ensure that all connections are tight and secure. Loose connections can increase resistance and reduce the effectiveness of the grounding and bonding system. Thirdly, inspect the grounding and bonding system regularly. This helps to identify any potential problems and ensure that the system is functioning properly. Fourthly, test the grounding and bonding system periodically. This helps to verify that the system is providing adequate protection. Furthermore, it is important to understand the difference between grounding and bonding. Grounding provides a path for fault current to flow back to the source, while bonding connects all metallic parts to minimize voltage differences. Both grounding and bonding are essential for preventing electrical shock hazards in pool installations. In conclusion, proper grounding and bonding are crucial for pool installations. By following NEC requirements and best practices, it is possible to create a safe and effective grounding and bonding system that protects pool users from electrical shock hazards. Consulting with a qualified electrician is always recommended to ensure that the grounding and bonding system is installed correctly and meets all applicable codes and regulations.